Hi everyone, my name is Monoranjan Gorai. I am primarily an architect and working for Sapient. And I had been with Java J2E technologies and DevOps, especially in a couple of years. And I had been working with lots of cloud technologies. And the topic what we have today is to understand DevOps and what are the areas of DevOps someone needs to be skilled with to get into a job or make it as a profession. So we will learn or know about those technologies, what someone needs to master at. So if each one of you can quickly introduce yourself, and then we will start the discussion further. Anand, would you like to introduce yourself?
Yeah, my name is Ananta Krishna. Past 8 years I'm working as a mobile developer, and recently past 1.5 years I'm working as a Java and Spring hybrid technologies. So I'm new to DevOps. So I want to and I'm interested to learn DevOps. That's all.
Okay, great. Kuram.
Hi, this is Parvamir, and I'm a front-end UI UX designer and working in uh, Pakistan, Karachi. I'm from Pakistan, Karachi. So I'm interested in learn the stuff you are teaching. That's from my side.
Okay, great. Welcome. Rohit.
Hi everyone, this is Mohit. I'm from India and I'm working as an application support engineer in Nathan Technologies for past 4 years. So I'm quite interested in learning in DevOps.
Great. Welcome, Rohit. Navid.
Hi everybody, I am Naveed, full stack developer, and working for a couple of years experience. That's all.
Utkarsh. Yeah,
Hi.
welcome, Navid.
Hi everyone, I am Utkarsh. I am from India. From the last 2 years, I am working for Atos Intel as a software as a manual tester plus automation.
Okay, great. Welcome, Utkarsh. Jishan.
Hi guys, I'm tech lead and architect in a US-based company working as a senior dev resource over there. That's all.
Okay, great. So you all are welcome to this session. How many of you have worked on DevOps, especially as a DevOps engineer or inside a DevOps team, or you are associated with a DevOps culture inside a company? Is anyone, or DevOps itself is a very, very new for you, each one of you?
It's
Like
new
I,
for
I
me.
work I work for outside the DevOps, but I want to learn like how it can be help to us.
Okay. What about Navid? Okay, so Navid says it is new for him. Okay, so let's get into the subject now. Okay, so DevOps, right? So it is dev comes from development, ops come from operations. Now, in any, can you all guys mute please and unmute whenever you need it. So any software when we develop, right? First is the package of the software we prepare after the development, and the next is it can be deployed anywhere for running that application or the software, right? So the development part is one portion in this loop, right? And operations portion is one portion. Now, in old ages, what used to happen is in a waterfall model, software used to be developed in one stage, and then next stage goes for operations or deployment, right? And then that complete all the steps used to be done one by one again. But when DevOps operations came, right, what happens is we link those two together and we run both continuously, rather than we take a few months for developing something and then send it to the operations for running it, because that has huge amount of gaps. So in this middle line, previously there used to be a huge gap. So if there is any issue in the operations, right, that used to come to dev, and when it comes back to operations again, it was taking a lot of times, sometimes in months, sometimes in year also, based on the type of the application. Now, by the time the new changes used to come to the operations or to life, right, business requirements used to be changed completely. So that changes or fixes were no longer valid in many cases. So people started to make this loop very closer and make it as fast as possible. Like the moment you develop something, we should be able to test it, verify it, and use it as soon as possible. So to solve that problem, this DevOps culture came. Now quickly in the development cycle, what we do is, first is you have the requirement. It could be small requirement, big requirement, whatever it is. You have the requirement, you do a planning on that requirement. And what that planning includes, definitely you have to do high level analysis, low level analysis, technical designs, right, architectures, and then you start coding. Plan is done, you write a code for the requirement and the designs what you have made. Once code is done, you build it, create the package or libraries, you test that in your testing environment, and then you release it. Now once you release it, the next onwards, the operations are taken by a different sets of people. So developers are developing it, testing it. So developers nowadays, we call them as a QA engineer or dev engineers, both together they do it. And in the operations, people normally create the machines. It could be physical machines, it could be virtual machines, and now they create containers, containerization, right? Using Docker, Kubernetes, etc. So they deploy those softwares and then they run in production environment for use. And what are the things they do? They do deployment of the software, they operate on it, and then they monitor it. So in the production environment, these are the three activities they do, main three activities. Now, while this is happening based on user feedback, customer feedback, or any issues which is found in production, or it could be any new enhancements which may come by the customer, by product owner, etc., that are pushed into development cycle again. Now, to reduce the gaps between developments and operations, we come up with, just a minute, I want to enable the point. So to reduce this gap, we create CI/CD, continuous integration and continuous development. Right? So this is the core of this bridge. The bridge which you make between development team or development operations and operations team or ops team or the operations is made by CI/CD. CI/CD is the solution for that. Okay, so now I have a couple of things quickly. I'll take you through what are the things I'm going to cover. We will know what is DevOps by definition, right? Why we need this culture, role of CI/CD in DevOps, and skills required to become a good DevOps engineer. So here I mention only DevOps engineer, but you can be an architect, you can be a specialist like this. There are so many different roles available in DevOps and on so many different technologies also. We are going to know what are the different tools used in DevOps and how those tools are developed. Which technologies are used to develop those tools. We are going to know what are the configuration tools, what are the containerized infrastructures related tools, configuration management tools, CI/CD tools. Is there any message as such? Role of cloud technologies in DevOps, right? So many are interested on this part, cloud technologies. What are the best cloud providers we have? Container orchestration tools, test automation tools, development methodology, architecture, alert and monitoring tools, APIM tools, mesh technologies, right? So these are the things which we are going to quickly discuss and be interactive at any particular moment. Whatever question you have, feel free to ask me so that I will help you to clarify your queries. So at this moment, does anyone has any query? I will send you this PDF to you also after the session. You will get the recording as well.
So far, so good.
Hmm.
Let's move on.
Yeah, tell me if you have any question.
So these are the things comes under DevOps, the technologies you said. So I just want to know, like, is this any specified DevOps operation? Like, for an example, if I'm interested in the cloud, so you, as you said, like there is a the cloud based some of the like best in clouds is AWS, Azure. So do we like while entering in the DevOps operation? So do we need any specified, or we need everything? We should have knowledge of every particular operation which you have showed earlier.
Yeah, very good question. So I think these are very, very important questions to know. So the point is, every company is existing in the world today. Each company will have different preferences of technologies, right? Now, I will give you a simple example. There are companies who develops using Java technologies, companies who are using C, C++. There are companies who are using .NET technologies, right? Now, similarly, when some company wants to host their softwares into cloud, now they also have the options of competitors. Now, who are those competitors? They are nothing but this AWS, Azure, Oracle Cloud, GCP, etc. So there are varieties of companies who use different of these vendors. Now, let's say when they are posting jobs for development of their company's softwares, so each company will tell that, okay, what they are using, and for that they want to hire or recruit people. So each company will have a skill sets required to develop their software. So now when you are new to the market, now it is not necessary, neither it is possible by one person to know each and every technologies. So it is good to do a market research on each of these technologies, which one is more used in the companies around the world, and learn that to get a job faster, so that you will have more job opportunities. Now, example. Now, you could be a Java programmer, you could be a C++ programmer. Now, when you come out from the college, you look at the market, you go to the job sites. Now, if you apply through by putting C++ in your resume, you may get less number of job opportunities or calls. You put Java, Spring Boot, microservices, you will get many opportunities. Similar thing is applicable when you choose which technologies of DevOps you want to master first. So that is how you have to decide which technologies you need to learn first, and how and what you need to proceed. In the same company where I'm working today for a client, so I used AWS, I used GCP, I used Azure, as well as I used Akamai Cloud. There were previous companies where I have used Oracle Cloud also. I have used IBM Cloud also. So what happens is, when you move companies, when you change projects within a company, different project group may select different technologies. Does it answer your question?
Yeah, got it.
So I will help you to select which technology to start with. If you are very brand new, so that we can discuss offline, or maybe in conversation. If we have some opportunity to explain that, I will help you to select the technology, so that you can learn that technology and start putting it in your resume, and build your skill around that technology. Is that fine?
Yeah, thank you so much.
Great. Any other question?
Yeah, I have a question.
Please go ahead.
So uh, by now we have understood that actually DevOps is a collection of mastering different DevOps tools. So do you think that every DevOps should be handled by a single person, or there should be different dedicated people to work on different DevOps, like there is a build processes, SCM tools, CI/CD, containerization and configuration management, infrastructure monitoring and crash reporting tools, and application performance monitoring. These are the tools, 7 tools which I have in my mind, which are part of DevOps. So do you think that a single person should take responsibility of managing all these areas, or there should be different dedicated ones to get
Right. It's
good?
also a very important question. Yeah. So I will tell you. I'll explain you. So it depends on the size of your project, and the usage of your project, and the amount of development or effort required to do all these activities. Now, there are projects which is used by, let's say, only 10 people, 100 people, let's say, and it has only very limited sets of features, like 5 or 10 features, right? Let's say in a school, you just need to submit certain forms. That's it. Submit some forms and see the status of that form. Only 1 or 2 workflow, right? Very small project. Now that also can be done in DevOps. You use all these tools, selected tools required in your complete life cycle of that project, and do it. Now that can be done by one person, very small one. But when you go to a project where you have hundreds of features, hundreds of microservices, right? Hundreds of Java core APIs to be developed, hundreds of infrastructures are required, right? So at that time, you cannot do it by a single person. So based on the amount of work required, you have to split it into different people. Now, when we say full stack developer, right? So You have heard the term full stack developer?
Yep.
Right? So what do we mean by full stack developer? So this is what it is, right? Full stack developer does everything. He does the analysis, design, coding, deployment, monitoring, testing, everything. Now there are different companies who assigns the work on different ways. Now there are companies who will tell you are a let's say feature champion, they will call. So what they will say is like you manage only forms which need to be submitted by the customers. So there will be one single form which will be filled up by customers and then they will submit. Now after submitting the form, what happens, they does not care about it. So there will be a particular microservice which will be used to accept the data from that form, okay, insert into the databases. There will be UI component, let's say AngularJS if you say, or DWR, GWT, anything, let's say UI component. So you develop a particular UI component. So in that case, you are a UI developer, you are a microservice developer, you are Java developer, you are a DevOps operator also. So you are doing a full stack, each and everything from starting from customer point of view to your production support. So looking at that way, the split or the formation of your team will happen based on the requirement of the project. Does it answer your question?
Sounds good.
Super. Anything else?
How we are
Okay.
going to start work in DevOps or using what is the learning path?
Yeah, sure. So I will go through now next slides. Let's see how it happens. And once I complete all the slides, you will come to know, you will have the answer for that, because that requires you have to go through this cycle. Yep. So let's move on. So I already told what is DevOps, right? So it is a set of practices that combines software development and information technology operations, which aims to shorten the system development lifecycle and provide continuous delivery with high software quality. So this is a like a text definition for the DevOps, but conceptually I explain you what it is. Now, why we need this DevOps? Why we need this DevOps culture? Main point is this: the business need. So in the time to market, right? How fast you can convert the requirements into a usable component. So that is the only goal with a best quality. So you have a requirement, develop it as fast as possible, deliver it to the production for use with the best quality. And whoever can shortest this time and expenditure, time and expenditure both are important. So you do it in shortest time with a minimum cost. Then only you can maximize your profit. So business need to remain competitive. Introducing DevOps is one way to achieve this. It allows organizations to increase the heartbeat of the development, put more rigor into testing. The speed of deployment makes it easier to work with, and it also gets changes out to the market sooner. Now, role of CI/CD in this. Now, initially I was telling you that CI/CD is the heart of it, of the DevOps, which bridges between these devs and operations, right? CI is the continuous integration, which is a part of the dev operations. CD is the part of the operations. CI in the development cycle, CD in the operations cycle. Though in your normal development and testing as a developer, you have to do both, because without doing a CD, you cannot test also. So in your development box, you do basically everything. But in real production environment, when you go, then these two get separated out. And for separating them out, there are again so many different strategies: release management, branching strategies, like artifact creations, management. So there are a lot many things which we will learn in the upcoming sessions. So textually, we say continuous integration and continuous delivery are often cited as pillars of successful DevOps. So these are the pillars, right? To establish and optimize the CI/CD development model and reap the benefits, companies need to build an effective pipeline to automate their build, integration, and testing process. So just note this term, effective pipeline. Right? What is this pipeline? So we say CI/CD pipeline. Right? What is this pipeline? So pipeline is a process basically which connects all the steps together into the into your development and testing deployment process, and it helps you to do automations of your complete operations, starting from your development to production, deployment, and support and monitoring. So that is pipeline. And how we do pipeline, I have certain slides to explain you. There are several tools used to do pipelines, develop pipelines. There are some coding languages as well to write pipelines. It can be done through UI, it can be done through coding, scripting, etc. So on this particular page, any question? You can ask any generic questions also, which is bothering you. Okay, let's move to the next page. So what are the skills required to become a good DevOps engineer? So in the DevOps area, you could be, you start as a developer first, normal engineer. You could be an architect, right? You can be end-to-end developer. You can be advisor, you can be consultant. So many things are there. So as much knowledge you gain, experience you make, that much better positions you can hold for that. Now, DevOps engineer make a bridge between developments and IT operations. Now, just note this portion. It says you are making a bridge between developments and IT operations. Now, if you go back to this slide, don't think that DevOps engineers are only in this portion of the loop, and developers are only in this portion of the loop, right? If you want to become a ops engineer, you need to understand complete life cycle of development also. You really don't need to write Java code or C++ code or JavaScript code, but you need to know how that applications are built using them. So that building portions you have to know how to connect them, how to compile them, how to create the folder structure, how to configure them. Those things you have to know. So if you are a DevOps engineer, it is better to do some development, start with some development in Java or any particular language you take, do some development of an application to understand heart of it, and then you start the ops engineer. So once you are a developer as well as you are ops engineer, then you can become an ideal DevOps engineer. Does it make sense?
Yep.
Okay, great.
Yeah.
So, is there any particular language? I mean, most of the languages is okay, but is there any particular language that suits us more?
Not really. Not really, because I will in my slides I will explain you what are the so many different areas where DevOps involved. and you will see for each area there are so many different languages is used, and it is very much practical that no one can master in all of this.
So you mean there is no preferred language for this tool?
No, preferred language is there for each of these areas. So DevOps again will be splitted into so many different areas. For example, one is, let's say, infrastructure creation. So how you automate your infrastructure creation. First part, right? Second is deployment of your softwares, right? Just you deploy. Third part, how do you do logging, searching, monitoring? Fourth, if I monitoring and alert, if I consider differently, alerting system, dashboarding, reporting, another system, right? So in each of these 3 or 4 areas, you have a specific languages to be learned.
Okay. Thanks.
All right. So so DevOps engineers make a bridge between developments and IT operations. So a good DevOps engineer needs to be a good developer or programmer with design skills, experience of software installation and deployments, networking knowledge, automation advisor, security advisor. Domain knowledge is an added advantage. So you see here what all required to become a ideal DevOps engineer or expert. But when you start your career, you cannot master in all of this together. Right? When I say all of together, see here, programming with design, installation of all the softwares, networking, you need a automation advisor, you need to be a security expert. So you can gain all those expertise months by months, years by years, by learning and continuously learning and enhancing your knowledge. Clear?
Yeah, got it.
Okay.
Yeah.
So now let's now I will focus on a specific portion as I was mentioning. Now in a DevOps, there are certain tools used, right? There are certain tools which are provided by certain companies or some open sources, which you can ready-made you can use instead of reinventing the wheel, right? And those tools are developed using certain different languages. So let's talk about that. So what are those? So the most popular languages used in DevOps are Golang, or popularly known as Go. Using this, we develop it is developed like normally technology companies does that. So you do not develop a Terraform, but you use Terraform to automate. You use Docker, but you don't develop a Docker container. You do not develop Kubernetes, right? So these are the technologies which we use to build our softwares or automate our softwares. And those technologies themselves are used using Golang technology. Golang. Okay.
So I have
Now,
a question. Uh, do the developers going for DevOps challenges have to do anything with what languages are used to build those tools? Because they should not care about what languages are used to build those tools, which are part of DevOps. So uh, will they be need? Will they be using actually those languages as well in some sort of scripting while using those tools?
yes. So let me explain this. Yeah, this is a very good question to split and focus on a particular area for your knowledge enhancement. So now let's say Terraform is a technology which is used to create infrastructures. Like you create virtual machines, you create load balancers into different clouds, or it could be inside your on-premise big machine, right? You do that. Now, they will have certain templates to be used, or they will have certain specifications where Golang might be used. So you do not need to be a Golang developer to do that. You just need a basic knowledge on that. But if you want to develop Terraform where it is being used as open source or inside some company, that time you need to be master on Golang. So knowing some basics of Golang will always help you to understand or use or Terraform or write scripts in Terraform to become expert. But it is not mandatory to know Golang. For example, you are developing a banking project using Java, right? So you need to know Java language. Now, Java itself is developed using some other language, right? Or other technologies. So you don't need to know that. So abstraction lies there. Does it make sense? For
Yeah,
example,
it does.
yeah. For example, you are going to use Docker to containerize your application, which you are going to deploy it into Kubernetes cluster, right? So you need to know Docker. So in this case, you not at all required to know Go language, which is used to develop Docker or Kubernetes.
So, yeah, so in the way like it is for an example is a application like having the load balancing. So we are using these tools to synchronize that particular application with the other load balancer IPs or other load balancers domains. You mean to say like domain? I mean to say like the other servers. So this is something you are saying.
No, so using Terraform, right? Using Terraform, we can create virtual machines. We can create not load balancer. We can create BPC. We can create a subnet, that complete networking stuff, and we can place those virtual machines or under certain load balancer, and I can put that cluster under certain networking and all. So these configurations are done using Terraform. Now, if you want to put a load balancer, multiple load balancer under a single load balancers, so those mappings also can be done using Terraform. Those all can be automated using Terraform.
Okay.
So it is basically whatever the manual work you do to create a load balancer, to assign whatever the components should be there under that load balancer, how you want to configure the load balancer itself to set certain properties, amount of load need to be allowed, what should be the size of that processors or memory, etc. of the different machines and all. So those everything can be automated using Terraform. Is it clear?
Yeah.
Okay, great. Now let's see the next. So this one was more focused on how you create the infrastructure. So you create the virtualization using Terraform. You create containerization using Docker and Kubernetes. So, and physical is now old, right? So now 3 ways of infrastructures are there at present. One is physical machines where you directly install your software. Next stage of revolution was virtualization, where we used to create VMs on a machine and then deploy inside the VMs. For that, we use Terraforms. And the latest new generation is containerization, where we use Docker, Kubernetes kind of technologies to implement containerization. So this is first point, talks about only your infrastructure buildings. Clear?
Yes.
Now let's move. Now once your your infrastructure is ready, right? What is the next step? You want to deploy your application into that machines. It could be machine, it could be your containers, it could be your virtual machines or physical machines, right? Now, to make the deployment as automated, you need this. You need Ansible or you can use Google App Engine. You can use TensorFlow, like PaaS applications available, right? And those are developed using Python. Okay, so Python is the master language which is used to develop these build tools. Similarly, Ruby is used to develop Shape, Puppet, Vagrant, Cucumber, etc. So using Safe and Puppet, also we can create build deployments similar like Ansible. So here you have a choice. Like if you want to create automated pipelines, you can choose any one of these technologies, either Ansible, Safe, or Puppet. In the market, Ansible is most popular, and then Safe, and then Puppet. If you want to be on the infrastructure side, you can start with Terraform, Docker, and Kubernetes. So when you ask me the question whether you need to master in each one of these, so of course no. You can have job only on point number 1. So you become a master on Terraform, Docker, and Kubernetes, you can get a job for a specific role. You become master in Ansible or Safe or Puppet, you can get a job. You now next is Scala, that is used to develop Spark, Kafka, etc. So this is not about the deployment, but it is about processing your application data, messaging systems, architecture. These are used in the DevOps culture for the big applications to manage in a better way. The next area is your Jenkins, which is used for creating the builds, automated pipelines, etc., which will use to call all these scripts together, link those scripts together, know the result of those status, monitor them, etc. So for 1, you have one job area. 2 and 3 gives you one job area of your career profile. 4th one gives you one career profile, and 5th one gives you a different career profile. So these are when you are starting your career. But let's say you are an architect, you are in and lead, right? Then you have to know all of this. Then only you can manage the project. You can lead the teams. You can be a lead of only one for Terraform, Docker container. You can be lead of this, but depending upon the project. If your project is small, then all this can be managed by one lead. But your project is big, like the project where I was working, we have 300 engineers itself, right? And we have more than 40 to 50 different product lines developed. So since I was an enterprise architect, I got to lead all of them. But I did not get all these skills in a day. I have got it in several years. And next, quickly on the configuration orchestration tool. So this was again linked with this point number 1, how we create the infrastructure. So Terraform, Packer, and also cloud providers are providing their own templating languages to build the infrastructure into those clouds. CloudFormation is one of them, which is from AWS. So if you are a AWS expert, you are AWS architect, then you can limit your knowledge within this to start your career. So do you have any question on this page before I move on to the next? You all are good?
Yeah.
Excellent. All right. So now this we spoke about this already in high level in the previous slide. Probably, yeah, I have given you the more all details already. So tools to build containerized infrastructure. So you want to build your career on this containerized technologies. You learn your Docker or Swarm. Swarm is now you can say backdated. Now people started to reduce using it. People more are going towards Kubernetes. It is much advanced than this, with a lot much support available. You go for Packer, you go for Helm. Now, when you are your organization, your application is small with only Kubernetes. When you have one cluster, two cluster, or maybe 3, 4, 5, you can still manage using only Kubernetes. But when your cluster goes to 40, 50, 100, thousands, you have to use something else to manage all these clusters. When you are in a legacy company where you have hundreds of applications in your old physical machines, you have in virtualization, and also you are moving to cloud in a hybrid model. So you have all kind of infrastructure in your system. That time you need certain automation tools to manage all them together. That time Packer, Helm will help. Packer will help you in the hybrid environment more, whereas Helm will help you on Kubernetes clusters more. Configuration management tools. So I already explained you about this: Ansible, Chef, and Puppet to create automated builds. You write scripts to deploy the builds into hundreds of machines, starting from one or two machine also. Use CI/CD tools like Jenkins and TeamCity, and you can use it just like a user, just to trigger one particular build. But it has again lots of like Groovy scripts. You can use, you can automate your pipelines, you can apply logics around, you can trigger emails, you can in the secured environment, you can create credentials, you can create authentications, you can permission models when you have very big organization structure. So there would be only admins working on Jenkins. There could be a 5-member team for only working on Jenkins to manage the tool itself, where your Jenkins server itself will be running into 15, 20 different servers, where I was working. Like every day, every hour, hundreds of applications are running in your Jenkins server. So managing the Jenkins server and Jenkins builds itself becomes a very big work. Same goes to TeamCity. So either you can choose Jenkins or TeamCity. Both are very good, but Jenkins is more popular. Any question in this page?
Not right now.
Right. So now we come to the cloud technologies in DevOps. Now, cloud computing promotes the DevOps culture within an organization. So the DevOps, whatever I spoke about, all these technologies, tools, scriptings, and all, right? Now, if you want to master everything, if you want to write the scripts yourself, you want to design, because each all of them require certain designs and architectures as well to use it for your application, right? Now, if you want to do everything in scratch, from the scratch, right, it takes lots of time and effort. So cloud companies have come up with certain specific tools with certain guidelines to help you out to achieve all those very easily. That could be creating your infrastructure, that could be creating pipelines, deployments, your data processing, management, data migration, whatever you call, whatever is required in a typical life cycle of a application.
So that facility will be in the form of some sort of UI, user interface, which we can operate via mouse and keyboard, or we will also need to write some scripts.
Right. So they provide all, starting from the UI, where you just need a mouse to click here and there and fill up certain forms, and it will do it for you. But that becomes tedious when your infrastructure is very big. That time you cannot go to, let's say you have 100 applications, you cannot go to 100 app form and make the configurations, change certain properties and all.
So
But if
for
you
a
have
sing,
very less
yeah,
number of applications,
yeah.
you can go there and you can do it easily.
Okay, it means if I have a single product, one
Yeah.
application,
Right.
then I can just use mouse and keyboard in their admin panels or whatever UI panels, and do things in all these tool set manually, right?
Yes, absolutely. Yes.
Okay.
Now, when you have so many things together and there is a link relationships among all those applications, some or other ways, that time we start writing the scripts. So they provide CLI, command line interface, where we can write the scripts. So they have a guidelines and a scripting language as well to automate everything so that we can manage all those applications together with a very less amount of effort. And repetitive work cannot be done. You don't need to do. You don't have to spend effort to do the repetitive work. So once you have automated, you can use that script again and again.
Okay.
So cloud technologies promotes the DevOps culture within an organization. Cloud technologies provide the flexible and user-friendly tools to the DevOps engineers to develop automated CI/CD pipelines. It provides on-demand computing power, storage systems, networking capability at most or at almost no effort compared to the legacy physical infrastructure. So here note three things. One is computing power, second one is storage system, and third one is the networking. These are the minimum thing you need for every application. Now, when your application grows big, the like number of users or transaction grows big, when amount of data goes big, when amount of data processing big, then you have to go to the other tools. For example, you might need Hadoop, you might need a Spark, right? You might need messaging systems. So those all comes as a different packages into this from this cloud technologies. So as big you grow, you can start adopting those technologies and integrate it into your system. But to start with, these three things are minimum required: computing power, storage system, and network. Now here I have mentioned some best cloud providers, starting from AWS, Azure, GCP, IBM Cloud, and Oracle Cloud. Now, out of these, AWS is still the market master. Azure and GCP is growing very fast, especially after Kubernetes was into the picture. GCP is picking up also very fast, but still it is behind Azure, I believe. But maybe it is a game changer in the next 1 or 2 years. So if you are selecting your career in cloud, you can select any one of these three to start with, but be sure that every company may not use all of them, right? So again, your job skills gets divided. I mean, number of opportunities gets divided among based on these technologies, but concepts around these tools or the cloud providers are similar. So let's say AWS is providing EC2 instance, right? GCP will provide you a compute engine. So they are similar. So computing power related technologies or the tools similar. Only naming convention is little different. Storage systems also similar. Here also you use certain databases. Here also you use certain databases. So if you can master on one, then others you can pick up very easily. So start mastering one, then start learning other concepts. You will be able to relate them. And when you go to interview, right, you can just switch your skill sets. That cleverly most of the people do. Like even you don't have worked, but if you have learned it well, you can just say that I have worked on it. That's the very clever, I think, lies are being done by all professionals. Do you agree?
So you mean to say, in other words, these are quite same, but the UIs are quite different.
UIs are also not quite different. They also will have similar kind of structures, menu, similar kind of forms, similar kind of properties, names, and all. They are almost similar. I would say 70% would be similar. So you learn one technology, when you move to other technologies, you will see 70% similarities are there.
So in other words, like Java and .NET, both are having OOPS concept are quite same. So this is something.
Right, absolutely. So if you are master on Java, I don't think it will take much time to program on C++. Some syntaxes, certain things will be different. Some memory management, some concepts will be different, but still you can switch your job in those. But not on all areas. For example, if you do swing programming or GWT programming from Java, that might be quite different than how UI is developed using C++. But yes, in general, as a normal core developer, you can compare them.
Okay, got that point.
We just need to know about there is a different domains in this in all this cloud about AWS. There is like a associate developer part and the system DevOps part.
So the job title, right, is different for different organizations, and they never map to a specific technology or different scope of the technologies. So let's say if you are a system engineer or if you are an associate engineer, right, that does not mean they are different. It for different company, you may like in the company where I work, they starts with the associate name, like associate engineer, associate lead, associate architect, okay, then architect, then senior architect, like that. But when we work on the ground for developing a software, you at the end you work on the core of it, either a coding or design or architecture of it. So job title will never match with the exact work with what you do. Even you might be a manager, technical manager, but you might not be managing any application. You might be doing certain good designs. You would be writing some frameworks, APIs, helping leads to fix the issues, etc.
Okay.
And to be with the IT industry, now it is very important that everybody has to code. Management, people management, those are now will become very, they will become an history very soon. So if you see in an agile environment, so other than product owner or business analyst who does only the functional part of it, remaining everybody codes on some or other way. If you leave a Scrum Master, but in many teams, Scrum Master also has to code. Does it answer your question? If you are not satisfied with the question, you can ask me cross question. That's fine with me.
No, I'm satisfied with this question, but I just need to know about the domain specific. As in AWS, there are the different domains. So
Okay, so
I'm just
hmm. So
need
when
to
you
know
say
about
about
that
domain,
though.
okay, so domain has a different meanings altogether. So let me try to understand what you are trying to specify here. So domain could be like healthcare domain, it could be e-commerce domain, it could be let's say security domain like that. So what do you mean by domain here? Do you
No,
do you mean the functional domain, or can you give me some
I just
example?
mean yeah, I just mean there is in AWS there is a different type of certifications as like a
Okay.
associate architect. There is a specialized one.
Hmm.
Next one is the associate like this. So
We
each
don't.
one uses a different. So each one uses a different functionality of AWS. So based on that, I need to know.
Okay, so they are not domains. Okay, so they are not called as domains. So these are some skills specifications for using or become expert into this in this tool, right? So they are different areas. Now, the domain in IT industry means that what I told you. When you say that, are you a domain expert? Now, you will be considered domain expert either in healthcare or e-commerce or let's say supply chain, etc. Right? now now coming to your point, when you say you are doing the certification, whether at associate architect or DevOps engineer or blah blah blah, or AWS architect like that. Now each one of them will have so many subject materials. Now each one will have common for all the basics. For example, what are the tools available, starting from your infrastructure, deployments, pipelines, your data sources available, your data processing, artificial intelligence or machine learning, messaging system, security, infrastructure, networking, etc. Right? Now you have to choose among of them what you want to do. You want to go on the infrastructure management, you want to go on the networking side, you want to go on the developer side, you want to become a data engineer or data scientist, etc. So that depends on your core interest, what you have decided in the starting. So first you have to decide, you want to become a, let's say you want to become a deployment engineer, right? You want to become a data scientist, you want to become a networking engineer, right? So like that you have to select your career profile. And
Okay.
once you select, let's say you have selected you want to become networking engineer, now you have to uh, build your knowledge on that vertical of networking. So if you learn only networking in AWS, then your jobs is limited with AWS users only, the companies who are using AWS. But if you improve your knowledge on networking, now you should learn networking in AWS, networking in Azure, networking in GCP, or in the normal physical infrastructure networking as well. So you have to select your career profile in that way.
Okay.
So you can, if you say that, okay, I am a AWS architect. Okay. Now within AWS architect, you have again these splits. You can be an application architect. You could be one networking architect. You could be a security architect. You can be a data architect. Okay. So now if you choose application architect, now application architect becomes a vertical for you, which will be again used across different clouds. So you architect basically application, but that can be for AWS, that can be for GCP, that can be for some other cloud as well.
Okay.
So that's how it works.
Okay.
Yep. Okay, so next is container orchestration tools. I told you about that, Swarm and Kubernetes. So Swarm is going outdated. Kubernetes has picked up a lot, and still this is the boom time for Kubernetes. So if you want to master only in Kubernetes, you can get a very good job right away. So there are many companies who are recruiting on people who are expert in Kubernetes. To do Kubernetes, you have to know Docker containerizations. Okay. Now let's see in the DevOps area, what are the testing automation tools we use. So Inspec is one of them, good one. Ready API, Karate. So these all are concentrated on API testing, virtualizations, containerization, etc. Okay, so when I say API, so that again goes to microservice architecture, where you build microservices, you expose your APIs, you use API gateway, etc. Right. So by leaving the legacy software development, now when we come to microservice architecture and development, these are the things, very important tools used nowadays. So if you are a test engineer, right, test automation engineer, you must know these things in the current age. So this is another career path for you in the DevOps area. So this will be all about you care about only automated tests. Now, when I say automated test, that could be automating the test in the infrastructure, automating the test in the build, automating the test in the deployment, automating the test in the normal functional testing, and then monitoring. During monitoring phase, normally we do the health checks and certain parameter tests. The process-wise development methodology, scaled agile, normal agile, what you say for a small organizations, Scrum, Kanban. So these are the very important process to be used to become a ideal DevOps culture company. So you need to, everybody needs to know nowadays, whether you are, if you are working in a company for software development. And architecture wise, so the latest new generation architecture is microservice and reactive architecture, right? Which starting from a small application to big applications, you can everywhere use it, but that does not mean that for everything you have to go for microservice. Still, you can have a single code base application based on your need, based on your amount of usage, transaction, data, and all these things. I have, okay, so one more page to explain. Okay, so the last ones is the alert and monitoring tools, where Splunk, Nagios, Grafana, Kibana, Elastic, etc. are being used. Okay, so these are the very, very important tools nowadays for alert and monitoring system in a large scale. In small scales, you can build your own some monitoring systems by yourself. But when you grow very big with hundreds of applications running, hundreds of clusters to be monitored, amount of transactions, a huge amount of logs being generated, so you have to choose these kind of tools. So these all again required for all DevOps engineers to know, because in whichever area you might work, you have to track logs, you have to track, what is happening in the productions or in different environments, and fix the issues. So for support, you have to know each one of this. Not each one of this, means whichever is used for your application, any one of these will be used in your application. The other one is the APIM tool. So when the number of APIs goes very big, a lot many APIs will be used, lot many microservices will be used, and to manage those microservice APIs and all, you have to use some API tools like APG, IBM API, APIM, Microsoft Azure APIM, etc. And each one of them might be your particular job area. So there are people who works only on APG, people who works on only IBM, and that basically in your initial phases of your career. But when you grow your career, you have to come out from it and you have to learn all other technologies to become a lead or architect or manager. But if you want to start, there are companies who are recruiting only the admins of APG, admins of API manager, APM. So that is also possible, but this opportunity will be very less. Mesh technologies. So these mesh technologies are mandatory when you have very large number of clusters for your Kubernetes or containerizations, or a lot many microservices are there. That time you need to build security infrastructure among the microservices. You need interaction between external communities to your microservices, internal interactions with your microservices, right? Security, data transfers, encryption, decryption, policies, your certifications and all. So these all can be managed single-handed with a nice UI or command or scripting through these technologies. So these mesh technologies is very, very important when you are very large scaled organization. So that's all I had today. Feel free to ask me any question. Maybe in another 5 minutes we will close it, and then I will publish what would be the next topic. And personally, you can message me what are the different interest areas you have. I'm planning to form different teams or different groups based on the technologies which you want to learn. So you can tell me what are the selected technologies you want to learn or you want to master, so that we will form groups for each one of them, and I will have sessions for each one of those groups. So this time I have come up with a very big plan. I don't know how much I will have time and do it, but I have a very big plan to continue it for long run. And I have done it before also in a smaller scales. But this time I have a bigger plan to do it across the world with forming so many different teams. And I will request people also to lead some of those topics. And that also will help you to become a lead going forward in the market or in your company.
Yeah, that's great knowledge share series of sessions. I really appreciate. Thanks.
Thank you.
Thank
Anybody
you,
else?
Mananjan sir.
You are welcome.
Hello.
Thanks for knowledge sharing.
Yeah. Hello.
Yeah, please go ahead. Thank you. Thanks,
Yeah.
guys. Yeah, please go
Yeah.
ahead.
It's very good session, and I have some doubt about some certification in AWS.
Yeah, please go ahead.
Yeah, we don't have any previous experience in AWS. We are very blank in that. Now we are start learning in that. If you want to do that AWS Developer Associate Certificate, so what are the things that need to learn, because we don't have any practical experience in that. So how to learn for certification stuff?
So let us do one thing. You send me a message by saying these are the technologies you want to learn. Okay.
Okay.
And what is your career aspiration? Career aspiration and technology. These two things you message me,
Okay.
so that based on that I will form teams, and then we will discuss on those particular technologies and tools.
Okay, sure. Okay.
What is your recommended platform or cloud for further enhancement?
For cloud, if you go see right now, AWS is at top, and then Azure, and then GCP. But the next generation, I visualize GCP is picking very fast. The reason is AWS being an e-commerce company also, right? The e-commerce companies are not using AWS. right? So because they don't want to disclose their secrets to AWS or Amazon, right? So GCP being a neutral in the industry as a neutral company, technology plain only technology company, not into e-commerce and all. So they are able to invade into all other industry, let it be healthcare or banking systems or financial or e-commerce. So I visualize in the upcoming years, GCP is going to be the big opportunity. Any other question, guys?
Okay, anyone from software testing background, what should you prefer for him?
Utkarsh
Software
here.
testing, yeah,
Yeah,
for
you can.
testing
Yeah.
back.
Yeah.
Sorry, go ahead.
Yeah, no, Mananjan, you just go ahead. I will answer it later.
Okay. So for testing, I would say go for microservice or API testing. So API testing, there are several tools. I mentioned 3 out of them. So you build your career. You can karate testing is a very hot topic nowadays going on. So you can go for it. Karate, Ready API, these two.
Okay, thanks.
So let me stop the recording and I will be available for another 5 minutes. You can ask me any question. Yeah, if you all are good, then we can close the session for today. Thank
So
you,
will it
everyone.
possible?